If you want to know how to make some cool mathematics videos, then keep watching. I'm going to show you how to make this square function using a sum of trigonometric functions. Go to Google, type in Desmos, click on Graphing Calculator, and that's us ready to start. We're going to draw a circle, so we need x squared plus y squared is equal to a value of 1. So that's going to give us a circle. Now we want to have a point on the circle that maps out the entire circle. So we do that by putting a point in. So this is a point here. Now the x coordinate of the point on the circle is going to be given by cos x1. And the y coordinate is going to be given by sin x1. So let's look at the slider here. As this slider moves, you'll see that point moves round about the circle. Now what we want to do is take a connection from the origin to that point. We do that by adding a table. So here's the table here. Now in this table we're going to go from the origin, which is point 0, 0, and we're going to go to the x and y coordinate here. So the x coordinate is going to be given by cos x1, and the y coordinate is going to be given by our sin x1. And you'll see that if we click on the dot here and we click on lines, it's going to give us a line from this point to this point here. And we could make the line coloured black or blue or whatever colour we so desire. So if we were to press play on this, you'll see that this line rotates round about the circle just as we require. Now let's tidy this thing up a little bit. We're going to put in a folder, and we'll call our folder square function, and we'll put some of the stuff inside it to keep it nice and neat and tidy. So we'll put these values in, and we'll just leave the slider out. So we've got the slider here, and we've got our circle, and we've got the first part of our simulation. We're going to put in another two phasors. One is going to rotate round 3 times as fast as this blue one, and the other one is going to rotate round 5 times as fast as this blue one. So let's put those in. We're going to add in a table, and we're going to go from the origin again, which is 0, 0, and we're going to go to a point on the axis, which is going to be the x distance cos x1 and the y distance sin x1. But now we're going to go 3 times as fast, so we're going to use the x coordinate will be cos 3x1 and the y coordinate will be sin 3x1. And we'll join the points, and this is our phasor here. And we'll put in another one which is going at 5 times the speed. So again we'll go plus table, and we'll go 0, 0, and this time it will be cos 5x1, and the other point will be sin 5x1. And we'll draw the phasor in, and we'll draw it in a different colour. And that's us got our 3 phasors. So let's tidy this thing up before we press play, and we can put these into the square function out of the way, so that we're just left with our slider. So whenever we press play in this, you'll see that these phasors rotate at a different rate. Now it's hard to see here, but I'll slow this down, and you'll see if we look at the blue one, as the blue one goes round, you'll see that the green one is actually going at 3 times the rate, and the orange one is going at 5 times the rate. So we've got 3 phasors here that are going at different speeds, and we're going to add these phasors up vectorially in order to generate the square function. In order to generate the square function, we're going to have to change the length of each of these phasors. So let's go in and put the correct lengths in. So the blue one is going to be the longest, and it's going to be given by 4 divided by pi. And also for the sine, we're going to have our 4 divided by pi. Now the next phasor is going to be this one here, which is in green, and it's going to be given by the length 4 divided by 3 times pi. And again, we're going to have 4 divided by 3 times pi. And finally, the orange one is going to be the shortest, and it's going to be given by 4 divided by 5 times pi. And again, we're going to have the distance here, which will be 4 divided by 5 times pi. So that's us got the phasors the correct length. Again, let's just tidy this up, and we can shift this along, and we can see that the phasor is rotating. Now it looks like the blue one is actually rotating incorrectly. So let's go ahead and we'll have a look and see what's going wrong with that. Now you can see the blue one here, the value here of cos x1 has been missed out. So let's press play on this again, and we'll see that the phasors are rotating at different speeds. So the blue one is rotating at the slowest speed, and then the green one is faster, and then the orange one is the fastest. But we want to add these phasors up vectorially. So I want to take this phasor here and add it on to this one here, and then add this phasor here onto this one. So let's do this one first. We want the new point for the origin here to be this point up here. So let's put in a new table. So we'll lift the table up to the point where we're looking, so just about here. Now what we want to do is make the point here for this phasor to be actually at the end of this one. So the end of this phasor here is going to be given by this 4 upon pi cos x1 and the 4 upon pi sine x1. So if you like, this is our new origin for this phasor. So this green point here moves up to this point over here. Now we have to find the other point. Where does this point go to whenever it shifts up along this phasor? So where does this point go to? Well, this point goes to the original point up here, which is going to be given by this value here, and also this value here for the y. But we're going to have to add on this extra distance here for the x, and this extra distance here for the y. Now we already know this distance here, because this distance is going to be given by the green function which we have here, which is going to be the 4 upon 3 pi cos 3x1. So we're going to have to add this value and also this value here onto this function. So we're going to add on plus 4 divided by 3 pi, and that's going to be times our cos 3x1, and at this point here we're going to have our plus 4 divided by 3 times pi times our sine 3x1. So this is going to be this new phasor added on here. So let's change the colour, and we'll change it to our green, and we'll make the line here. So now you can see that this phasor here has been added to this point here. So let's tidy this up again, and we can see that as this moves round in a circle, you'll see that that green phasor here moves around the same as this green phasor, but it's been shifted. It's been shifted to the end of this blue one. So we've done the vectorial sum of this phasor and this phasor, and I'll let that play out so you can see it running round, and you can see it running round in the circle. Now what we have to do is the same, but we have to do the same for this orange phasor. So the orange phasor is going to have to be added on to the end of this green phasor. So the new origin for this orange phasor is this point up here. So let's go and do that now. So now we have to add this phasor here onto this phasor. To get the new origin, we have to take this point here and shift it up to here. But we know what this point is because we've just worked it out. So let's have a look and see. We just worked it out a second ago and we've seen that it's going to be this coordinate here. So if I say Control C and we'll create a new table, and in this new table the origin is going to be this point here, and it's also going to be this other point here for the y. So you can see this in black and we've picked the right point. But now what we have to do is we have to take this point here and shift it up and add it on vectorially. So also we know how to do that as well because we know how to get to this point. To get to this point, again, we just have what we have up here. Control C, Control V, Control C, Control V. And now we're going to have to add on an extra factor. So the extra factor that we're going to add on is going to be given by the x component of this little orange phasor and also the y component of the orange phasor. But we know the x component and the y component. We've already worked those out. Those are given by this value here. So we're going to have to add this component onto this one here. And we're going to have to add this component onto this one here. And you can see straight away, well, it looks like we've got the right spot, but we'll change the colour for this one. And we'll change it to the same colour here, which is our orange. So you can see here now that we're going to have the three lines added up vectorially. So let's clean this up again. And you can see that as I move this round about, you can see that all of those three phasors have been added vectorially. Now what we're interested in doing next is we're interested in the position of this endpoint here, because the position of this endpoint here will map out our square function. Now before we do that, let's get rid of this circle here because it's no longer needed, and let's put in the actual circles for this point, and also this point. So let's start off with the red circle. You can see that the red circle here has got the wrong diameter. It should have the diameter which is this blue line here. So let's go in and we'll find the circle. Now the red circle was given by the very first equation we put in, which was our x squared plus y squared equals 1. Now it's no longer equal to 1, it's equal to this length here. Now what is this length here? Well, just by Pythagoras, it's going to be the x squared distance of this point plus the y squared distance of this point. Now we know the x distance and the y distance of this point because it's simply going to be our distance here, which is given by our 4 upon pi cos x1 and 4 upon pi sin x1. So it means that we can, instead of having the value of 1 here, the length here is going to be 4 divided by pi times cos of x1, and it's going to be squared, so, and that's to the power of 2, and also for the y component it's going to be 4 divided by pi times sin x1, and again it's got to be squared. And there you see that we've got the circle, and you see it's the right diameter. Now what we'll do is we'll change the colour of the circle, so it's the same colour as the radius here. So the colour of this circle is going to get changed to blue. So now that's one of the circles done. We have to do also for the green one, so let's do that next. So let's first of all add our green circle in. Now we'll copy the circle we've got here for our blue one, and we'll use that as our basis. So we'll go Control C, and we'll add a new circle in here. We'll go Control V. So that's just a copy of this previous blue one. But we don't have the right diameter for that, the radius for that circle. So the radius for this circle here is going to be this distance here, which is the x coordinate of this green point, and also the y coordinate of the green point. And those coordinates have to be squared. So what are those coordinates? We'll have a look at the graph. There you can see for the actual circle, we're going to have 4 upon 3 pi times cos 3x and 4 upon 3 pi sine 3x. So this value here is going to be 4 upon 3 pi cos 3x1 and 4 upon 3 pi sine 3x1. And you can see here that it does give us the correct circle, and it's got the correct radius, but it's not positioned in the right point. This circle here should actually be centred at this point here. So how do we shift the circle over to this point? Well, we can take the left hand side here. In order to get the right position, it's going to be x minus the distance here. Now this distance here is going to be given by our blue circle, and the blue circle x distance is going to be given by the distance here, which is going to be 4 upon pi cos x1 and 4 upon pi sine x1. So if we take those values away, so we're going to have, instead of the x squared, we're going to have x, and we're going to have minus 4 divided by pi times cos x1. And of course this whole thing has got to be squared, so we'll put it in the brackets. And we'll raise that up to the power of 2. And you can see here it's shifted this along to the correct point. Now we're going to have to shift it up. So again, we have to shift it up by subtracting off the value of 4 divided by pi times our sine x1. And of course that all has to be squared. And that's raised to the power of 2. And you can see here now we've got the green circle in the right position. So let's tidy this thing up a little bit. We'll take this and we'll put it in to our folder, and we'll make the folder minimized. And you'll see as we move this round about, you'll see the green circle revolving round about the blue circle. Now there's one other one we have to do, and this is the final one here, which is the orange circle, and it has to rotate round about this point here, which is the little orange point. So let's go and do that point now. So now we're looking at the little orange circle. So what we'll do is we'll copy the green circle and we'll change it. So let's go ahead and we'll copy this green circle. So that's the green circle here. And we'll copy that, Control C, and we'll create a new circle. We'll go Control V. Now let's just make this smaller. So this is all that we're looking at here. Now this is this red circle here, but we want it actually to be the diameter or the radius given by this orange line. So it's got to be this x coordinate squared and that y coordinate squared. Now we already know the values for these. Instead of being our 4 upon 3, it's got to be 4 upon 5, and it's going to have to be our 5x1, and it's 4 again upon 5, and it's got to be our 5x1. Now you can see here that we've got the circle here, and it's the right diameter. It's the same right radius. It's the same radius as this one here, but it's not in the right position. It has to be positioned up here. So the centre has to be at this point. So how are we going to get the centre at this point? Well, again, we take away the new extra bit of information, which is the x and the y coordinate. So again, we can take away now the minus 4 upon 3 pi times our cos 3 x1. And on this side here, we can take our minus 4 divided by 3 pi times our sine 3 x1. And you can see that we've now got the circle positioned in the right point, but we'll change the colour of it and we'll change it to the orange colour. And we'll also stick it into our folder here. So now as we turn this round about, you can see that the circles are actually turning correctly. So I'll move this out a little bit. I'll move this across, and we can see that we've got the circles rotating as we want them to rotate. So the last little part that we want to do is we want to take this point here and we want to generate our square function from the locus of points generated from this little orange point here. Now we'll draw in our square function and we'll connect our square function up to this orange point here, and we'll see how this height of this orange function actually maps out the square function. Now just for quickness, I've put our square function in here. We're interested in the height part of the square function, which is given by the sine part. So we've got our 4 upon pi sine x, 4 upon 3 pi sine 3x, 4 upon 5 pi sine 5x. And this maps out our square function. So if we click on that, you can see we've got our little square function appearing. Now we don't want the entire square function, we're only wanting it between certain ranges. So we put in these curly brackets here, and we're wanting it really from the range of x is got to be greater than 0, and it's got to be less than our value of our x1, so it's less than x1. So you can see here that it generates this function here as we move along. So you can see the function being generated in orange. Now I've only done it for the positive axis, okay? So I could have done it for the negative axis as well, but we'll just leave it for the positive axis. But what we want to do is we want to see that the height of this little point here actually maps out the height of this function all the way along. So we're going to join this point here to this point here. So let's go ahead and we'll do that, and it'll be the last part of our simulation. So that's us almost there. Let's just do this last little section and that'll be us finished. We're looking to get this point here. Now we know this point here is going to be the x coordinate of the blue line, the x coordinate of the green, and then the x distance here of this orange. And again, for the y height, it's going to be the y height here of the blue, the y of the green, and y of the orange. Now I've already put the table down here, and I've made it a little bit larger so it's a bit easier for you to see. So the x coordinate here is going to be given by, well, it's the x coordinate of the blue one, which is our 4 upon pi cos x1, and then we're going to have our x coordinate of the green line, which is 4 upon 3 pi cos 3x1, and then the x coordinate of the orange line, which is 4 upon 5 pi cos 5x1. And again, the same for the y coordinates, but the only difference to y coordinates, it's not a cosine, it's going to be the sine. Now that's going to give us this point here. Now the other point that we're looking to get is the point here on our square function. Well, the x coordinate of the point here in our square function is easy enough, it's just our value of x1, and then the y coordinate of our function here is simply going to be this height here, which again is just going to be the 4 upon pi sine x1 and 4 upon 3 pi sine 3x and 4 upon 5 pi sine 5x1, just the same as we had above here. So if I was to click on this and join the two lines together, this is going to give us our connection between our phasors, which have been added vectorially, and the function which we are creating. So if whenever I draw that in, you'll see this point connects to that point here. So that's us finally finished the whole design. So now if I was to move this round, you'll see the moving round exactly, or apart from the negative side, okay, it only works for the positive values. So it goes round from the positive values, okay. So what we can do is we'll just stop it really for the value for x is less than 0. So if I click on this here, and we can say x is greater than 0 and less than, well, to go all the way around it must be 2 pi. So finally that's us finished our little design here. So what we'll do is we'll go on just in the last 2 minutes and we'll make it all nice and beautiful, the same as the introductory part of the video. So that's our simulation finished. We want to generate something that looks a little bit smarter. So if we head up to the little spanner here and you click on that, you can see here we can reverse the contrast, we can turn off the grid, and that's going to give us, we put it into projector mode as well, and that's going to finally give us what we're looking for. So I can press play on this and I can minimize this here, and you can see that we've got the final simulation completed. Now if you would like to record it, you just make sure your recording area misses out any of the rest of this stuff in the top, so you just get this little area here, and that will generate a very nice square function. And it's a nice simulation to understand how the square function is generated from the sinusoidal functions. And this really is us looking at the Fourier series. So that's us finished with the simulation. It was quite a long simulation, but I think if you've gone through it in detail, you'll have learned quite a lot. So if you liked the simulation, then don't forget to subscribe, hit the like button, and leave a comment. I'll catch you later.